Hi, my name is April Taylor, and I'm excited to share with you an in-depth look at a first grade standard in the geometry domain. My passion for mathematics education exploded during the teaching mathematical thinking professional development I attended years ago. I started seeing connections between mathematical ideas I never had before. Finally understanding concepts that always eluded me was such a thrill. I strongly desired these same opportunities for my students. My mathematical journey took me through completing a master's with a focus on mathematical discussions based on student reasoning in early elementary grades. I had the opportunity to work with teachers as a math coach, support district level mathematics professional development, and make connections with the larger math community in the area. The highlights of my teaching career center around students' ideas and the joys they get when they recognize the value of their own mathematical thinking and learning. I sincerely hope that the information we will work through together will support you in your professional goals and teaching career. I've been in the education profession for nearly 20 years, and most of my career has been spent working with early elementary students. During my time in the classroom, there were many opportunities for me to deepen my understanding of and engagement with student learning of mathematical concepts and effective math teaching practices. Based on what I implemented and learned in my classroom, I had the opportunity to be a K-6 math instructional coach for 5 years. I've also had the experience of teaching kindergarten and first grade for D91 Online Academy. I currently live and work in the Idaho Falls area. Today, we will address these essential questions as we dive deeply into one of our first grade geometry standards. We will see how students build on these first grade geometric ideas. We'll engage in math tasks to play with the conceptual ideas and what we can expect our students to reason about. We'll analyze samples of students' geometric thinking along with Van Healy's levels of geometric thought. This information will give us insights into our next steps for our students. And all along the way, we will explore and share resources available to increase learning opportunities for you and your students. If you're with yourself or with a group, you will want a notebook or a journal, and we'll use this to capture our important ideas and a place to play and think about the math. The entire video is approximately 60 minutes long. Slides 1 through 11 are about 13 minutes. Slides 12 through 27 are about 22 minutes. Slides 28 through 38 are about 14 minutes. Slides 39 through 43 are about 5 minutes, and slide 44 is about 5 minutes. You can find the timestamps for each of these questions in your show notes so that you can watch this video in smaller segments. Which of these shapes do you think does not belong? Take a moment and pause your video. Give yourself time to think of your idea and your reasons why. Share out your thinking, and then when you're ready, restart the video. Isn't it interesting that there are reasons for each shape to not belong? We are going to be working with the standard reasoning with shapes and their attributes. And we do this by comparing defining attributes and non-defining attributes of 2 and 3-dimensional shapes, building shapes and that possess those defining attributes. So before we get too much further into this, let's take a moment and think, what do you already know about shape attributes and what qualifies as a defining or non-defining attribute? Take a moment and pause, either share out your ideas or record your thoughts, and when you're ready, move on to the next slide. As you can see, mastery of 5 key kindergarten geometric standards are essential for student success in engaging with and mastering this first grade standard. In kindergarten, students strategically play with shapes to recognize, name, and visualize shapes mentally and in their surroundings. As students play, explore, draw, and build shapes, they are also developing their spatial reasoning. To really understand the depth of this first grade standard, let's engage in tasks and explore what geometric reasoning looks like by analyzing samples of student work and thinking. The intent of this standard is for students to understand what makes shapes similar and different by recognizing attributes and geometric properties. Additionally, classification of shapes is also based on these same geometric attributes and properties. Using defining attributes as descriptors, students will be able to compose and draw shapes. Access our show notes and get the document entitled Shapes All Around Us. We're going to take some time to independently read over this case study. And then when you're done, either engage with a partner, small group discussion, or journal on your own answers to these questions. Take a moment, pause the video to do that, and when you're finished, come back. Now let's order some of the responses students made along this learning trajectory. Start with comments that may be at foundational levels of geometric understanding towards comments that indicate more understanding of these mathematical ideas. Pause and take a moment to do that. Back to our show notes, access the document entitled Levels of Geometric Understanding. We're going to be using this for the next few slides, so keep it handy. The husband and wife Van Hiele team developed a hierarchical model explaining how spatial and geometric ideas develop with descriptors of the spatial thinking and geometric reasoning that occurs in each of those levels. Originally, the Van Heeles developed 5 levels, but Clements and Battista hypothesized an additional level, pre-recognition. The levels progress sequentially, and progression is not age-dependent. Progression is based more on geometric reasoning experiences. A learner's level may vary from concept to concept, like we saw in the student responses in case 1, where descriptions of squares were more mathematical than other shapes. Van Heele's theory explains why many students encounter difficulties in their geometric courses, especially with formal proofs. The Van Heeles believe that writing proofs required thinking at a comparatively high level, and that many students need to have more experiences in thinking at lower levels before learning formal geometric concepts. Up through level 1, students recognize whole shapes and then they start to see and identify properties of shapes. The last 3 levels really focus on seeing relationships between the properties and forming proofs and theorems. In the pre-recognition stage, students may be able to name some of the shapes, but they will not see specific distinctions or attributes that would define that shape. In our show notes, grab the document Colin's discussion with teacher. We're going to look at this example of Colin, who is in the pre-recognition stage, and this is his reasoning when asked to put shapes that are alike in a circle. Maybe we could have 2 volunteers read out the different parts in this dialogue, or just read it independently. But once you're finished reading it, then on the Levels of Geometric Understanding handout, draw a picture or write a word that summarizes the key idea of this level. Go ahead and pause the video and take a moment to do that. In the visualization stage, students see shapes as a whole. Again, not really seeing the properties, and most often shapes are related to real-life objects. In the visualization stage, if students are shown shapes in the orientation displayed on the left-hand side of the screen, they probably would be able to name them because they're kind of shown in their traditional orientation. But if the shapes are turned in a non-traditional orientation as shown on the right, they might not be able to recognize or name those shapes. On our Levels of Geometric Understanding handout, write a word or draw a picture that captures the understanding at this level. Pause, take a moment to do that, come right back. Think for just a moment about your textbook or curriculum and the images of shapes that are shown. How might the images help or hinder students moving through levels 0 visualization? Take a moment, pause the video, discuss, or journal. Pause the video and take a moment to read over this slide. Level 1 analysis is at the heart of our first grade standard of distinguishing between defining and non-defining attributes of shapes. We are really exploring the properties that make a shape what it is. This is hands-on and helps to build conceptual understanding. In our Levels of Geometric Understanding handout, draw a picture or write a word that summarizes the key idea of Level 1. Pause, take a moment to do that, and come right back. We will come back and explore this level some more. I think continuing along the Van Healy levels of geometric understanding will help us better understand how critical this first grade geometry standard is for our students. At the abstraction level, the definitions of shapes are becoming more specific and clear. We can see relationships between properties within a shape, as well as how that allows us to categorize shapes into subcategories. So let's do an activity to engage with level 2 abstraction and explore relationships between properties. In our show notes, access the handout Hands-on Geometry Activity 4 Quadrilateral Sorting Laboratory. Once you do that activity, go to your levels of geometric understanding handout and write a word or draw a picture that summarizes the key idea of level 2. Pause and complete those two tasks before continuing on to the next slide. Once we've had multiple experiences recognizing shapes, analyzing their properties, and seeing relationships between the properties, then we're in a position to successfully cope with the proofs of Euclidean geometry that students work with in high school. Most adults are at level 2, and it takes time and many opportunities to be prepared to reason geometrically at level 3. At level 3 deduction, students are moving from thinking about properties to reasoning or proving things related by relating them to the properties. Students can construct proofs and supply reasons for steps in their proof. Postulates or axioms, definitions, theorems, and corollaries begin to develop, and this is usually more high school level work. An axiom or postulate is a statement that is considered true and does not require a proof. It's considered the starting point of reasoning. Axioms are used to prove other statements, and they are basic truths. For example, the statement that all right angles are equal to each other is an axiom and does not require proof. We know that all right angles are equal to each other, and we do not argue that point. Instead, we use this information to prove other things like theorems. For example, in triangle ABC, line segment BM is a median. And with that, I can prove that the area of triangle ABM is equal to the area of triangle MBC. These postulates and theorems relate directly to the work of Euclid around 300 BC and his 5 postulates that are assumptions about lines, angles, and other geometric concepts. Euclid stated 5 postulates, from which he proceeded rigorously to prove more than 450 propositions or theorems. He built our system of geometry. His 5 postulates are: it is possible to draw a straight line from any point to any point. It is possible to extend a finite straight line continuously in a straight line. It is possible to draw a circle with any center and distance, radius. All right angles are equal to one another. Given a line and a point not on the line, there is exactly one line parallel to the given line. Starting with these 5 postulates and common assumptions, he developed some of the most important theorems in mathematics. On our Levels of Geometric Understanding handout, draw a picture or write a word that summarizes the key idea of Level 3. Level 4 is all about taking those postulates and theorems and applying them to different situations. For example, spherical geometry is based on lines drawn in a sphere rather than on a plane. For example, how do axioms relate to different types of geometries? We see this kind of work at university levels. On our Levels of Geometric Understanding handout, write a word or draw a picture that summarizes the key idea of Level 4. Pause to read this quote on the screen, and then take a moment to journal or share out what connections or experiences you've had related to this quote. Now that we've seen the whole progression of geometric thought and logical reasoning, let's dive deeper into Level 1, which directly correlates to the geometric work we will do in first grade. By first grade, students should know and use the following terms: shape, two-dimensional, three-dimensional, rectangle, square, trapezoid, triangle, cube, cone, and cylinder. Given this task, Here are four triangles. What do all of these triangles have in common? What makes them different from the figures that are not triangles? In this task, students may informally identify shapes where corners touch and shapes where corners do not touch. This gives us a great opportunity to teach vocabulary in context with meaning. We can introduce students to the terms open and closed figures. How might we complete this sentence? All triangles, but only some triangles. So pause, take a minute, give yourself some think time, record or share out your ideas before starting the video again. Here are four rectangles. What do all of these rectangles have in common? What makes them different from the figures that are not rectangles? While students are engaged in the triangle and rectangle task, they are probably informally describing the properties of shapes they see. This is a great opportunity to teach the vocabulary terms of sides, square corners, and vertices in context. How could we complete this statement? A rectangle is... Pause, give yourself some think time, share out your ideas, record your ideas, then come back and restart the video. We may complete this statement by saying a rectangle is a closed shape with four straight sides and four square corners. At this Van Hiele level and first grade standards, students are not yet thinking of how properties relate to each other and forming subclasses of categorization. We are really focusing on identifying and defining attributes and properties of shapes. So with that in mind, how could we complete this sentence frame? A square. Again, pause the video, give yourself some think time, share out or record your ideas, and then restart. Maybe we would have completed this statement by saying, a square is a closed shape with four sides of equal length and four square corners. This task can be found in our show notes. We're going to take a minute to engage with it and then have a discussion based on our engagement. So you may want to use index cards or tracing paper to explore and describe the shapes. Then when you're done with that, have a discussion or journal out which shapes on the bottom row did you determine fit the criteria and why. Go ahead and pause the video, engage in your independent activity and discussion or journaling, and then come back. At this level, we're not expecting students to master the vocabulary of parallel or congruent. However, they may be recognizing that the sides run alongside each other, parallel, or that the sides or angles are the same length, congruent, identical in form. Students may notice space between the lines that make up a corner are different, acute angle, obtuse angle, right angle. Vocabulary is so critical in developing our understanding and giving us the language to describe our world. Tasks like these allow us to present vocabulary in a meaningful way, just when students are needing it to express their ideas and observations. This triangle sort activity can be found in our show notes. We are going to sort these triangles in some way so that no triangle belongs in two groups. After we sort, then let's have a discussion or journal out, kind of sharing how you formed your groups and why you did what you did, your reasoning. Go ahead and pause the video, engage in your independent time in discussion or journaling, and then come back. Although first graders are not expected to identify equilateral, obtuse, and acute angles, we can start pushing them to recognize regular and irregular shapes. So regular shapes would have equal sides and equal angles. Again, we can be on the lookout for opportunities to introduce vocabulary such as equilateral triangle, keeping in mind that our students are not held responsible for using these specific terms yet. In our show notes, we'll be able to find all the documents we'll need to engage in this task. We will need the parallelogram handout, the rhombi handout, rectangles handout, and the square handout. You may also want to use index cards to help us check right angles and compare side lengths, as well as tracing paper for identifying angle congruency. So either in a group or by yourself, you're going to work with one type of quadrilateral. And we are going to explore and be ready to share out how we can describe the sides and angles of that particular quadrilateral. So take a moment, pause the video, engage in the task, engage in a discussion, and then come back. By engaging in multiple exploration tasks with discussions, students would now be ready to play with games and activities where they use their newly described vocabulary to draw and build shapes. In our show notes, you will find a link to a virtual geoboard, or if you actually have physical geoboards handy, go ahead and pull those out to play this game. We can do this a couple of different ways. I can present you with a challenge, pause the video, build the challenge, and then we'll keep going for a few minutes. Or if you'd like, with a partner, create a challenge yourself to give your partner a shape that needs to be created. The key to remember is that each challenge would need to describe one or more properties of the shape to be created. So if you would like me to give you the challenge, let's go ahead and get started. Otherwise, pause the video and play on your own for a moment. Can you make a shape with only one square corner and four sides? Another challenge, can you make a shape with two square corners? Or maybe we could even enhance that. Can you make a shape with 3 or 4 or 5 or 6 square corners? Can you make a shape with 2 pairs of parallel lines? Can you make a shape with 2 pairs of parallel lines and no right angles? In summary, as teachers, we are providing opportunities for students to meaningfully engage with geometric vocabulary. We are creating situations where students explore and discover defining properties of shapes. We are also providing opportunities to create and build shapes based on those defining attributes. Students are composing shapes, and they're using geometric vocabulary to specifically describe and have discussions about shapes. Let's analyze samples of student work and diagnose where they may be at along Van Hiele's geometric progression. Students were asked, which of these shapes are triangles? This assessment really captures the idea of our first grade standard, and these are samples of 3 third graders' responses. So how would you categorize the mathematical understanding and misunderstandings of these kiddos? And what Van Hiele level do you think they're at and why? Pause and discuss or journal your ideas, and then come back here. In first grade, we would hope to see students know that any shape with 3 sides and 3 angles is a triangle. Patrick seems to know that a triangle only by its traditional orientation and shape, whereas Angelina seems to have mastered this first grade standard. And I would find it really interesting to have a chance to visit with Allison a little bit more and dive more into her thinking. This is another assessment we could use with our first grade standard. This task was given to 120 students near the end of their third, fourth, or fifth grade year. Take some time to analyze this data. What do you notice and wonder? Pause, share out your ideas, and then come back. How would you categorize the mathematical understandings and misunderstandings of the students who selected only shape B as a rectangle? How would you categorize the mathematical understandings and misunderstandings of the students who selected shapes B and C? How would you categorize the mathematical understandings and misunderstandings of the students who selected shapes B, C, and G? Mastery of our first grade standard was demonstrated by students who selected shapes B and G. They know that a rectangle has four sides made up of two parallel lines and four right angles. What implications does this data have for us as educators? Take some time to discuss and then come back together. Individually read over this quote and be thinking about what connections to your classrooms you might be thinking of and what your next steps might be. Pause, read, have a discussion, and when you're ready, come back together.